a short introduction about myself. I'm Garima Bajpai, based out of Ottawa, Canada. If you don't know me, I'm the founder for the DevOps community of practice here in Canada, which has multiple chapters: Ottawa, Montreal, Toronto, Edmonton, Atlantic provinces. I encourage you to check out our meetup sessions, events, and all the activities in the community, what we do, and also do get connected with our chapter leads in each of these chapters. Also, we have face-to-face meetups. If you want to join those and get close to the community, that is another option. Today, I have a session on Kubernetes ecosystem, and I would also like to introduce that we will be having some copies of the upcoming book from Pact, 50 Kubernetes concepts every DevOps engineer should know. So if you're interested to get hold of one of the copies and get a chance to win this copy, check out our face-to-face meetups. Again, Kubernetes ecosystem, it's a very, very interesting topic. So we have made some videos and done some sessions in the past over Kubernetes. So if, let's say, you are a beginner, and usually I start my sessions with basics here. So if you are looking into basics of Kubernetes and looking for an introduction, check out our session, What is Kubernetes? Introduction to the Kubernetes World for Beginners. It's a tutorial which we have done in the community of practice, and you can check out the video in the channel. I will also give you the link in the description box. So let's quickly get started with Kubernetes ecosystem. Of course, let's be mindful of, I will present a lot of tools, right? Some of these tools I have played around, I have taken help from various books, blogs, and also community leaders. So obviously, this is an introduction session just to get introduced to the various tools which are available for Kubernetes and why they're existing. So let's demystify the buzzwords for Kubernetes tools. Let's get started. So my first slide on this topic would be integration with cloud providers. So if you're starting your Kubernetes journey, I would recommend create a Kubernetes cluster to start with. If you're using Azure, there are few options for containers. So if you're primarily using Kubernetes, Azure Kubernetes Service, AKS, is the primary way to run Kubernetes workloads inside Azure. If you're working with AWS, EKS is the primary way to run Kubernetes inside AWS. And when you're using Google Cloud, they have JKE, one of the services, which is basically creating and running Kubernetes and also management of Kubernetes. Now, there's another interesting aspect if you are going multi-cloud. For example, scaling out Kubernetes workloads from AKS to GKE. This is an advanced implementation, and it will require security, IAM policies, and networking concept by and large. And you should also look at like cross-platform implementation of these things. There are also tools available for that, and we'll talk about that. There are other cloud options like DigitalOcean managed Kubernetes, Linode Kubernetes engine, and there are multiple other cloud pals who are developing services for Kubernetes management. So do check out that. So obviously, I cannot cover everything in this session. Probably we'll have to kind of do other sessions as well to ensure that we get a deeper dive into these tools. But for now, let's take on the next tool. Operate with the Rancher. So you might have heard about Rancher. Rancher not only deploys production-grade Kubernetes clusters from data centers to cloud to edge computing, it also unites them into centralized authentication, access control, and observability solutions. So think about like a multi-cloud platform for Kubernetes. This is one of the capabilities of these tools. Other comparative tools in this space will be Red Hat OpenShift Container Platform, which is an open source enterprise grade Kubernetes platform. Merentis Kubernetes engine, formerly Docker Enterprise or UCP, is also full-featured enterprise Kubernetes engine with complete management web UI. So you can also check out these. And there are other similar tools available, but we'll not mention all of them for the sake of getting other progressive tools into this session. My next take on this topic with ecosystem is managing Kubernetes resources with Helm. Now, if you have heard about this tool, I will demystify what this tool does. So Kubernetes being a container orchestration tool, it can present a steep learning curve for many of individuals who are beginning their career into Kubernetes. So one tool that can help running workloads on Kubernetes is Helm. How it works and what it does is Helm helps you manage the life cycle of Kubernetes applications. What it means is Helm is an open source tool, of course, and is used for packaging and deploying applications on Kubernetes. It works with charts, which can be considered as Kubernetes packages. Charts are also easy to create, version, share, publish. So start using Helm and stop the copy paste of your environment configuration. The Helm client and the libraries are written in Go programming language. Configuration files are, when possible, written in YAML. So obviously, this is one tool which by and large is being used by the community who's working on Kubernetes. Now, there are other similar tools. We will talk about that. For Helm, there are three important concepts. The chart, which is a bundle of information necessary to create an instance of a Kubernetes application. The config contains the configuration information that can merge into a package chart to create a releasable object. And a release is a running instance of a chart combined with specific config. When integrating Helm into your infrastructure, you can use it to package your own services or use charts that were designed by the community. I've linked a few videos and Helm architecture if you want to start with these components and these tools. Obviously, I will also mention it in the description box of the video. Now, there are other similar tools in this space. So I will mention Kustomize. Kustomize is another tool in this space which allows you to build a Kubernetes application as a series of layers and patches, empowering limitless customizations. The tool is built into kubectl as a version 1.14, which means it is now native in Kubernetes. And however, you can also install it independently. It also produces some challenges when it becomes native to Kubernetes, because it's also hard to kind of develop features independently, so on and so forth. But Kustomize does not offer many features, of course, as Helm does. And the native version embedded in kubectl is much older than the current standalone version. So that's what I was referring to. And this is embedded in most prominent examples of orchestration and continuous deployment tools like ArgoCD, Flux, and Kubestack. So these tools are in the same space. So I present a comparison table. This is something which I have sourced from one of the blogs, which I think I've also put a link on it in this slide. So features like templating or overlays, packaging, validation hooks, rollback, native Kubernetes integration, declarative nature, visibility and transparency. We've tried to compare in this blog, the author has tried to compare these two tools. And of course, it also depends on your situation. Like when you're starting to use the tool, how do you choose the right tool? There are several things you can look at, but I'll give you 2 pointers. Are you planning to write all the configuration on your own? So basically with a lot of customization, then you can look at how Kustomize can help you in this. Helm templates, on the other hand, are easy, faster, him, and also available on the fly. I mean, there is also a community which is constantly working on these charts, which are like provided by the community. So, I mean, again, different people have different experiences about these tools. I'm only sharing my experience. I then talk about ArgoCD, and this is a leap because if we want to talk about ArgoCD and how it is getting integrated with Kubernetes, we'll have to take a step back. Before we appreciate automated deployment using ArgoCD, let's figure out the basics. So we'll talk about GitOps first. So GitOps was coined in 2017. GitOps is essentially a framework or a group of best practices for how to manage cloud-based infrastructure. There are many definitions of it, but I prefer to use this one because I think it explains a little bit more from a beginner perspective how GitOps is integrated in the Kubernetes ecosystem. Now, Git plays an important role in GitOps. Git is used as a single source of truth for what infrastructure and applications should look like based on declarative configuration. So there are 4 main characteristics of GitOps which it brings on the table. It makes infrastructure like the declarative nature. The entire system has to be described declaratively. So looking at the end state, version and immutable. The canonical desired system state is versioned in Git. So you can version it and you can also make it immutable in that way. Pulled automatically. So obviously approved changes are automatically applied to the system and it's a pull mechanism. Continuously reconcile software agents to ensure correctness and alert on divergence. So basically they look at the state of the infrastructure and also continuously try to reconcile it with what is available in the repo. So these are the 4 characteristics. Now, why are we discussing GitOps here? Is GitOps is primarily making and creating best practices to manage cloud-based infrastructure. Now, when we start talking about CI/CD and in the integration of Kubernetes in that CI/CD ecosystem, using ArgoCD gives developers the ability to control application updates and infrastructure setup from a unified platform. So ArgoCD provides continuous delivery tooling that automatically synchronizes and deploys your application whenever a change is made in your GitHub repository. By managing the deployment and the lifecycle of an application, it provides solutions for version control, configuration, application definitions in Kubernetes environments. So it can handle several types of Kubernetes manifest, including JSON-net, customize, Helm charts. We have talked about this. And YAML and JSON files, and also support webhook notifications from GitHub, GitLab, Bitbucket, and all that. So it is one of the very, very interesting development and evolution in the space of CI/CD connected to Kubernetes. Now, when we talk about ArgoCD, we also have to talk about Flux. So Flux is a tool in a similar space connected to CI/CD, originally developed by Weaveworks and now incubated under CNCF. Flux is a set of continuous and progressive delivery solutions for Kubernetes that are open and extensible. Flux requires a customization in a Git repository. ArgoCD has a web console using user management. Flux does not have, and it is also very limited in the user interface. Flux bootstrap commands install and make the system monitor itself. ArgoCD does not by default. You have to need ArgoCD autopilot. So these are like some comparative points, but of course, as I said, it depends on your team, how are you intending to use it, and also your to a certain extent your experience. Now we will talk about security tools. So there is a lot of security tools available for Kubernetes. I will talk about few of them, but you can check out there are number of blogs on Kubernetes security. There are white papers, reports, as well as GitHub repositories for tools for Kubernetes. So you can check out all that. But for now, I think I will stick to some of these tools. Kubelenter is an open source static analysis tool, also referred as lint or linter, that identifies misconfiguration and programming errors in Kubernetes deployments. Kubelenter analyzes Kubernetes YAML files, Helm charts, and checks them against various best practices, which focus on production readiness and security. Kubelenter is taking a path to a chart and runs a series of tests to verify the chart is well-formed and error-free. Now, it comes with prepackaged 40 built-in, or I think it might be more now, checks for common Kubernetes misconfigurations, like running a container as a user, mismatching selectors, storing sensitive data only in secrets and all that. And then Kubelenter can be added to any continuous delivery or continuous integration tool, including GitHub Actions, Jenkins, Circle CI, Travis CI, and can automatically check for and identify errors in application configurations. So you can also check the GitHub repo for Kubelenter for documentation, health support, and community. I will discuss about security tools, which are also connected to, again, static analysis in a different way. Kubebench is one of the popular tools, which is an extensive static analysis tool that draws ideas from a benchmark created by Center of Internet Security, that's CIS. So Kubebench can run statically like Kubelenter, but can also do its scanning against a running cluster. That's a difference. And Kubebench was developed and released as open source by Aqua. Now, each version for Kubernetes requires slightly different benchmarks, and the relationship between Kubebench and CIS, Kubernetes benchmarks, is in flux. So the tool consists of a mix of YAML and Go language files. Again, you can check the security tool. There's a GitHub repo and also a community behind it. I will also talk about another tool, which is in another area, Open Policy Agent, or OPA. OPA is not a vulnerability checker like previous tools, but instead, it is a set of policies with a runtime daemon to implement them. OPA is similar to a firewall enforcing all kinds of limitations on activities within Kubernetes, adding policy controls and OPA through either an API or a CLI. The language in OPA express policies is Rego. Rego is complex, but it allows easy nesting of rules so that you don't have to repeat yourself, and policies are expressed declaratively. Obviously, we had done some work on this in the last summit, where we have a session, Shifting Policy Management Left with OPA Gatekeeper. If you're interested, you can check out that session, which does a deep dive into this, how it is being implemented, and what are the pros and cons, and other details. So I will actually produce a link into the description box if you are curious to know more about this tool. Now we talk about monitoring, observability, and optimization of Kubernetes ecosystem. So if, let's say, what we mean by monitoring, Kubernetes provides insights into your system's performance, health, security, and cost when connected to Kubernetes itself. So resource metrics such as CPU utilization or memory utilization, disk utilization at both node and pod level. Control plane matrices such as etcd data stores, API servers, controller lifecycle, and scheduler status. Matrices related to cost, such as Kubernetes cost per environment, product, team, cluster. And lastly, container native and application matrices. So all this has a number of tools to do that. So I'll introduce some of them which you can check out. So for monitoring, I would also refer to this new stack report. You can actually check out the report. It depicts how the community is using these tools, and which are the most popular tools. Some of these tools are like general tools you might be knowing, like Datadog, Neuralink, Sysdig. I'll not talk about those. I think I'll more focus on three tools: Prometheus, which is one of the most popular open source monitoring solutions. It does not come with a built-in visualization tool though. For that, you will have to use another tool called Grafana. So Grafana is an open Kubernetes visualization platform, an open source solution for querying, visualizing, monitoring, alerting, analyzing matrices, traces, and logs. Another tool to watch out for is KubeWatch. Kubernetes Watcher, tracking specific Kubernetes events. As soon as those events change or occur, it pushes the notification to multiple endpoints like, Slack and PagerDuty and whatever your integration would be in that space. So these are tools in this space. I will then also introduce some more interesting tools. One of that is Goldilocks, right sizing resources. What it is doing is optimizing your Kubernetes clusters to ensure that you set CPU and memory requests and limits on every cluster or every container. Fairwind, Goldilocks is an open source utility that can help you identify a starting point for your resource request and limits. Fairwind offers a platform called Insight, and users can centrally manage Goldilocks across clusters consistently to ensure CPU, memory, request, and limits are set effectively. Some prerequisites to use Goldilocks is like some of the tools like kubectl, Helm chart, matrix server, vertical pod autoscaler, and pods in the Goldilocks demo namespace. And of course, there are other details. We had done a detailed presentation at the DevOps Summit 2022 on Goldilocks. If you are interested, you can actually check out that session. I will introduce that link into the description box. And if you're interested, you can actually get some details around it. The next tool I talk about is KubeCost. It's a continuous cost optimization tool for Kubernetes. It tracks Kubernetes cost across different cloud providers, including Amazon Web Services, Google Platform, Microsoft Azure, Kubernetes, air-gapped, and other on-premise tools. KubeCost presents cost by matrices like deployment, namespaces, clusters, services, and more. Allocate cost to organization concepts like team, individual application, product, project departments, or environment for showback and chargeback. And other tools in this space is OpenCost, was originally developed and open sourced by KubeCost. So KubeCost, again, another interesting tool to watch out for. If you're interested, you can also check out their GitHub repository and their documentation. Last tool I would introduce today is Kubeflow. And this is a machine learning toolkit for Kubernetes. Kubeflow, the cloud native platform for machine learning operations, pipeline, training, and deployment. What Kubeflow is doing is it has integrated a number of tools in that space. Like Kubeflow includes services to create and manage interactive Jupyter notebooks. Kubeflow provides a custom TensorFlow training job operator that you can use to train your models. And then you have Kubeflow pipelines in a comprehensive solution for deploying and managing end-to-end ML flows for your machine learning models. Kubeflow is also integrated to like Selden Core, an open source platform for deploying machine learning models on Kubernetes. They have other integrations like NVIDIA's they are, I think they also have integration on the GPU level, and how to kind of create and manage GPU optimizations, and also other tools in that space. So we have also done a detailed deep dive with Kubeflow in DevOps Summit 2022. If you are interested, you can check out that. I will drop a link in the description box. With that, I come to an end of this session. Of course, I did not cover a lot of tools, right? I mean, I just covered the tip of the iceberg. There are a lot of tools which in each of these spaces, management tools, security tools, monitoring of the optimization, observability tools. So I would suggest that you check out these articles, blogs, GitHub repositories. And this is a curated session where we have put together information from various sources. And primarily these 4 books. If you're interested in Kubernetes, I would highly recommend to check out these books. The Kubernetes Bible to start with, 50 Kubernetes concept every DevOps engineer should know. If you are interested, let's say in tools like Rancher, they have Rancher deep dive tools, and they have other tools, books on other tools as well. Lastly, I would recommend the Kubernetes Certified Kubernetes Administrator CKA 2022 book if you want to get certified and get some hands-on experience and also validate your knowledge in Kubernetes. Again, or the publisher for these books is packed. And again, this is a very, very brief session about the top tools, which probably I have experience with some of these tools, and also I have taken references from the community leaders to ensure that we include some of these tools. So now I would like to sign off for today. And I hope that this session was useful for you if you're beginning to investigate and start building an ecosystem around Kubernetes. And in case you are curious to know more about our community, do join our face-to-face meetups, do subscribe to our channel, and also get in touch in case you need any support or help. So signing off for today, Garima Bajpai from Ottawa. See you in the next session. Bye for now.